Problem 106, Quantum Mechanics. The question is, a phase shift of 30 degree is observed when a beam of particles of energy 0.1 mega electron volt is scattered by a target. When the beam energy is changed, the observed phase shift is 60 degree. Assuming that only S-wave scattering is relevant and that the cross-section does not change with energy, the beam energy is. In the present problem, S-wave scattering is given. For S-wave scattering, L is equal to 0. Therefore, the total cross-section is 4 pi by k square sine square delta 0, where k square is equal to 2me by h bar square. Therefore, for S-wave scattering, we can write sigma is equal to 4 pi h bar square by 2me sine square delta 0. Thus, we can say that depending upon the value of E and the phase shift, we have different values of the cross section. Hence, sigma 1 is proportional to sine square delta 01 by E1, and we can write sigma 2 is proportional to sine square delta 02 by E2. Here in this present problem, it is given that the cross section does not change with energy. Therefore, sigma 1 is equal to sigma 2. Therefore, we can write sine square delta 01 by E1 is equal to sine square delta 02 by E2. In the present problem, it is given that the phase shift delta 01 is 30 degree, corresponding to the energy 0.1 mega electron volt, and the phase shift is 60 degree, that is delta 02 is 60 degree. We have to find out what is the corresponding energy, what is the corresponding beam energy. Let it be E2. Now we can say that E2 is equal to E1 sine square delta 02 by sine square delta 01. Here E1 is equal to 0.1 mega electron volt. Therefore, E2 is equal to 0.1 into sine square 60 degree by sine square 30 degree. This is equal to 0.1 into root 3 by 2 square divided by 1 by 2 square. And the answer is 0.3. Hence, we can say that the beam energy is 0.3 mega electron volt. Hence, option B is correct.